Hello and welcome. In this video, we're going to take another look at our P6 Modified, and this particular version of our P6 Modified focuses on a kiosk inventory application or a small business inventory application that reads in a CSV file of products. Basically, it parses it into an array of structures, ultimately does some sort of search or other operations. And you might find this video useful not only for this particular project, but also for other projects. Now, in this video, we are going to be focusing on the conversion or the differences between the search structs by string exact function, which was found in the original P6, and we're going to look at how we modify it to get to our P6 modified. But first, what's the difference between our P6 and our P6 modified? Well, in the original P6, we used static memory allocation. In other words, basically in our main, we simply allocated enough room for 100 elements. And if our file was not that big, well, we just used too much memory. If our file was bigger than 100, well, then we had the problem of stopping at 100 rows in our file. So again, there were some limitations there, and what we're doing is we're trying to get around those limitations. Now, in the earlier video, I actually focus on the differences between the original function and this new version of the function with the dynamic memory allocation using realloc. So I'm going to be a little quicker in this particular video. If anything, go back and take a look at the one where I focused on the double version of this function. And so only thing I'm going to point out real quick is the difference between the function signatures in that in this case, I'm essentially going to be able to update the indices address inside the function by using realloc. So if anything, what we can do is we can go back to the original P6 version of the function where we were passing the indices as a statically declared array, and we would just simply update the values in the array, but we couldn't actually change the array, and more importantly, we couldn't change the size of the array. And so what we can do is we can go down to the function, and we're actually just going to borrow the code. In other words, I encourage you to go to the other version of this video, in other words, the one that focuses on the doubles, to look at a more in-depth explanation of the differences. In this video, I'm just going to do it. And so we're going to go ahead and copy and paste the code. We're going to make some relatively significant changes in the code to, again, allow for us to do our memory allocation inside of the function. And specifically what we're going to do is we're going to comment out or remove the parts of the code that aren't relevant in the dynamic memory allocation scenario. And so particularly, we cannot simply assign a value. We have to make sure that we have enough room. And so the first thing that we're going to do is we're simply going to remove all of, or comment out all of the the updates in our indices array where we're simply just assigning a value. In other words, we first have to check to make sure that our indices array is in fact large enough. And so we're going to be making a couple of changes with each of our for loops. Also, we'll do this one block at a time. I'm going to focus first in on the ID branch, the name branch, and then the type. You could argue that you could simply just go ahead and delete the other two branches and then add them. Again, whichever process makes sense. We're going to focus in on the ID branch, and then I'm going to quickly make the changes on the other. So first and foremost, we need to check our input arguments, and specifically the one that we don't have to worry about checking in this scenario will be our indices. Why? Well, because it turns out that if we do have a null indices passed or a null value for indices passed, that is not a problem because that is actually what we are going to assume. The only other thing that we should probably consider adding to our validation of our input arguments is the value of n. It is not terribly detrimental if it is negative. However, we want to catch this possibility. If anything, just inform the user then of the possibility or of the fact that our n was negative. In other words, it was past a negative value for the size of our search struct, which again, we're going to catch inside of our for loop or a while loop, but it's best if we go ahead and handle it here in that we'll just simply provide an error to the user that says, please provide a non-negative n followed by a new line. And then more importantly, what we want to do is we want to switch our results now to exit failure. Now, let's get started on the changes that we have to make to accommodate our dynamic memory allocation. The first thing that we want to do is we don't want to assume that our indices point to a valid point in memory or valid place in memory, or put another way, that we assign a null address to our indices to begin with so that we aren't leveraging some other place in memory or some other unexpected place in memory. Again, depending on the type of application that you were working on, you may do this a little differently, but our first step is just to simply take our indices and we are going to cast it. In this particular example, we are going to be working with integers, so we're going to cast to an int pointer the value of null. And essentially what this does is this orphans whatever block of memory was already pointing to by our indices. Now, again, we can come back to this in later videos. I'm just going to put a little note here that we want to reconsider this. We probably want to consider freeing up that block of memory so that you don't end up with a memory leak. But because we have control over this also in our main, then we can simply make sure that there is not some additional block of memory that has been earlier allocated. The other thing that we want to do is we will ultimately want to flip our for loop into a while loop. As a matter of fact, we actually can go ahead and look at those conditions. We've talked about this in earlier videos. We essentially want to exit the while loop gracefully in the event that there is a problem allocating memory. In other words, realloc fails, for instance, to allocate enough memory. Well, we simply want our while loop to stop gracefully, and that means that we only want this while loop to run while results are equal to exit success. The other condition that we wish to follow or track is that our search index is in fact less than n. And effectively at this point, this makes our for loop moot, so we can go ahead and comment it out. I'm going to leave it here just so that we have some comparison of the two afterwards. But we also want to initialize then our search index, and we need to make sure that we are ultimately incrementing our search index inside of our while loop, because otherwise basically what we have written then will be an infinite loop. So again, down here at the bottom, at the end of our while loop, regardless of whether or not we find a match, we simply increment our search. Now, what is actually different about the if statement? Well, it turns out the if statement itself is the same. However, what we do after we have a successful match changes. In the earlier incarnation of this function, we would simply just assign the search index to a place in memory of the indices array, and we would assume rather naively that the indices array was large enough. And the reason why we could make that assumption is, well, in our main, we simply made the indices array the same size as the search structs. And so in other words, if you matched every single structure, it wasn't a problem. In other words, if we had 100 structures to search and all of them matched, well, the indices was already the same size as the search structs array, there was no chance of stepping out of bounds of memory. However, you would agree that that is a terribly, terribly wasteful use of memory, particularly in this scenario where you have only, let's say, 10 elements in the file to read. You've allocated 100 blocks of structures or 100 structures in the array, and to add insult to injury, you have also allocated 100 integers. So in other words, basically, if you matched 1 out of those 10 rows, you've wasted 90 times the structure size as well as 99 times an integer size. So I think you probably convinced at this point that that was not a good use of memory. Well, how can we fix that? Well, what we'll do is we'll make a call to realloc and make sure that we can allocate enough room in our indices array. And as a good practice, whenever you make a call to realloc, you simply want to store the results of realloc in another, in this case, integer pointer. And we're just simply going to call this one new indices. And again, the idea is that we want to be sure that realloc was successful before we attempt to access a new location in memory. So what we can do then is inside of the true branch of the if statement, in other words, where we have in fact found an exact match, we will simply first make a call using our new indices. We're going to cast again to an int pointer, whatever realloc returns. And remember that if realloc gets past a null value, it simply behaves like malloc. Again, it's convenient use of the realloc function. And in this case, we're going to pass to it the indices. And specifically here, I need to go ahead and do our address here. So this is going to be the address then of the array of integers that will store the matches. And then we want to grow this. And to grow this, what we do is we use the size of the actual matches or the number of matches. So in this case, it is going to be the M, which keeps track of the number of matches, and we simply want to grow it by 1. And then we simply multiply this times the size of an individual integer. Now, note, before we go any further, that this is technically a little bit inefficient. And why is this inefficient? Well, because if you had a large number of matches, you would effectively be doing a large number of reallocations, which every reallocation is going to take a little bit of time and also has the potential of shifting the address of the array in memory. So we'll come back to this in a later video. We'll talk about how we can improve this. But for right now, what we're going to do is just recognize that while we are definitely being more efficient with our memory usage, we might actually be a little bit less efficient in the time it takes to reallocate that memory. And again, for this example, we should probably be fine because we would envision only a few matches in our file. At this point, then what we want to do is we want to check to see if our new indices, in other words, that new memory allocation was successful. If it was not successful, realloc will return a null. And at that point, then basically what we want to do is printf an error, failed to reallocate memory, or failed to allocate memory. At this point, you've got a bigger problem than this function. In other words, something has gone wrong, and we simply want to say results are equal to exit failure. Now, this comes back to why we wanted to have that condition in our while loop, because now basically in the event that we fail to allocate memory, well, we simply set the results equal to exit failure, which stops our while loop and then essentially returns control back to the calling function in a graceful way. There are a couple of other ways that we can go about doing this, and I spoke about this in the earlier video. However, this is the one that provides a single exit point from your function, something that I highly encourage. Under the else branch, then what we want to do is we simply assign to our indices variable the results of the realloc, now that we know that it's successful, and that is going to be in the form of our new indices value. And at this point, then what we can do is we can leverage then that new indices, again with parentheses around them, because we are trying to get access to the array. And we simply leverage then our M to store whatever value we found for the match, or rather the index of the value that we found that matched. And so this portion of the code looks pretty similar to the one that utilized the static memory allocation. The only difference is how I am accessing the array. And again, this is just simply going to be a syntax in C that you're going to have to get familiar with. This is basically saying that I'm trying to leverage the address of the array and then an individual element in that array. At this point, then what we want to do is we want to increment our M, and we simply move that then inside of the else branch of our if statement. At this point, we should have all of the pieces updated to handle dynamic memory allocation. Probably before we go any further, let's go ahead and build this just to see if we have any typos or any errors. Looks good. And at this point, then what we can do is very carefully then bring over the portions of the code. You can't just blindly copy the entire while loop. You'll actually have to very carefully reach in here. And particularly, we're focusing on the portion that is in the dynamic memory allocation. And we want to simply update then each of the other loops. We'll start first with the portion in between the if statements, or rather in the if statement, if you would. The second step that you want to do is you want to go ahead and switch over the for loop into a while loop. Again, you do this for all branches of your outer if statement that focuses on the field name. And then the third step, of course, is you need to remember to increment the search index. And again, you do that regardless of whether or not you have found a match, because otherwise you're just going to be spinning an infinite while loop while looking through the search structs. Now, you might have found this easier to simply do one of the branches of your outer if statement and then copy and paste and then go back and modify. In other words, basically what's different between the three? Well, we could see here that instead of trying to match the ID, we simply match the name and the type based on the outer if statement. And again, I'm going to go ahead and build this just to make sure that I don't have any typos. It looks very promising. We will test this particular function when we assemble our application. But as always, I hope you found this video useful. If you have any questions, comments, or concerns, don't hesitate to reach out to me. And thank you for watching.